Hello everyone, my name is Abhinaya. Today let us see the topic Floyd Warshall Algorithm. It is also called as the all-pair shortest pair algorithm. As the name suggests, it gives us the shortest path between a pair of vertices. Let us consider this example containing four vertices A, B, C and D. Like it gives us the shortest path, this algorithm, from A to B, C, D and B to C, D and A, similarly C and D vertices. It is found out using the formula Dij equals minimum of Dik plus Dkj, Dij, where I, j are the vertices and k is the number of iterations. Before looking through an example, we should remember that Floyd Warshall algorithm is applied for directed or undirected graph, but it should be a weighted graph. Let us see an example. Here if you see that there is no directions given, that is except for this place. So when the distance is considered, the given weights is for 3 to 4, 5, but the other way around it doesn't work. Let us first fill the distance matrix, that is D naught. We see that there is no loops for self loop of any vertices, so the 1 to 1 distance will be 0. Similarly 2 to 2, 3 to 3, 4 to 4 and 5 to 5. And next 1 to 2. 1 to 2 we have the value as 3. And 1 to 3 we have the value as 10. 1 to 4. 1 to 4 we see that there is no direct edge connecting 1 and 4. So the value will be infinity. 1 to 5. Similarly 1 to 5. We'll fill the other one, rest of the thing, that is from 2 to 1, again 3. 2 to 2 is 0. 2 to 3 there is no direct edge, so infinity. 2 to 5. 2 to 4 it is 5. 2 to 5 there is infinity. Let us see the last third one. 3 to 1 we have 10. Since it is not directed, the weights given can be taken for both the ways, that is from 1 to 3 and 3 to 1. Let us see for fifth vertex 5, where from 5 to 1 there is no direct edge, so it is infinity. 5 to 2 there is no edge, so infinity. 5 to 3 there is no direct edge, that is since the direction is this side connecting 3 to 5 and not the other way around, there is no direct edge connecting, so the value is taken as infinity. And from 5 to 4 it is 4, 5 to 5 is 0. Let us see the first iteration, okay? That is k is equal to 1. We have known the formula Dij equals to minimum of Dik plus Dkj, Di, j. Here Dij represents the vertices between which we are taking the distances, and k is the iteration, and Dij is the previously known value, that is from this distance matrix we'll take that value and then we'll compare the minimum values. There are few rules to be followed. That is, when doing the first iteration, k is equal to 1. So the pivot row and pivot column entries will be same as the previously used matrix. That is, here k is equal to 1. So the first row and first column will be filled same as the previous D0. Next, the zeros will be entered the same. So the remaining are this in the second row, and then we'll start filling others. First let us consider in the second row D2, 3. So D2, 3, at first k is equal to 1 will apply in the formula. So we get Di, j equal minimum of I1 plus D1j, Di, j. So let us start for 2, 3. This minimum of D2, 1, that is D2, 1, that is 3, and D1, 3, that is D1, 3, 10. So 3 plus 10, Dij, that is previously used value of 2, 3. 2, 3 is infinity. So 3 plus 10, infinity, that is 13, infinity. Minimum is 13. So the entry is 13. Let us just circle to know that the values change from the infinity, okay? And then the next D2, 4. We get similarly minimum of D21 plus D14. That is 3 plus infinity, infinity. The minimum is infinity. Similarly D25. We fill the rest of the matrix in a similar fashion. After continuing the matrix, that is using the formula and the algorithm up to k equal to 5, we get this matrix. Where we can observe that all the infinities from the initial matrix have been converted to the distance that is shortest distance from the algorithm. You can see that from 1 to 4 was infinity, but now it is 8. Let us see, like 1 to 4, I think by cross checking we'll get to know it is 8 and not infinity. Similarly, all the infinities have been changed to the minimum shortest path between each of vertices. Thank you.